Okay, let's go ahead and begin. So, before we get into class, we have an exam coming up, like I mentioned last time. And I've been talking with Mr. Merzinski, and he is going to be giving his exam on Wednesday. So, he was planning on giving it Thursday, but because of some scheduling issues with some changes due to the coronavirus, the test has been moved to Wednesday. And if you want more information about that, I believe Mr. Merzinski has sent an email out, or you can of course ask him. So our exam is going to be tomorrow. I'll send out an email letting you know when it actually goes up, but it should activate tomorrow at 1 p.m. Okay? And that exam is going to go over all of Chapter 2, which is the stuff that we've been covering, and we're going to finish up Chapter 2 today with our class. I will be giving a review on Hawks. That review is going to be just like any of the others. You can take it as many times as you want until you get a score you're happy with. Hopefully that score is 100. You can view worked examples. You can do all the things that you need to do to review for that exam. Okay, so let's go ahead and get into the lesson for today then. So last time we started talking about solving equations that were in a quadratic form. And we said that we could use factoring to solve some of them, which, if we can use that, cool. We can also use the complete the square method, which is kind of like a foolproof, it will work every single time. And, we have a particular way we know that it factors. We know that if we can get that factored form, we can then solve it. It's a nice method to use. Now, today, I want to show you something that's kind of similar to that. We're still going to be solving things with quadratics, but it's going to be higher order quadratics. So, first things first. So we have x squared minus 1 squared then minus 14 x squared x squared, minus 1 plus 48 equals 0. Ooh, that line kind of got away from me. Okay. So if we were to, not factor this, multiply this out, so distribute and square and everything, we would get a higher order quadratic. Specifically, we would get a equation with a leading coefficient of 1 and degree of 4. So we haven't seen anything like that. However, there's actually an easier way to tackle this, and we don't want to actually multiply things out. What we want to do is we want to say, well, we have factors here that match. In particular, we have the x squared minus 1s that match. They are the same thing. So what we can do instead of multiplying things out is we can replace these with something that represents them. Having x squared minus 1 there is kind of making this a little bit more complicated looking than it actually is. if I were to replace x squared with minus 1 with something, let's say x squared minus 1, let's try that square again, is equal to, I don't know, m. Then I can rewrite this as m squared. And we have an x squared minus 1 here, squared. This is just m now. Minus 14. Again, we have an x squared minus 1, so we'll replace that with m. Plus 48 equals 0. Now, if we look at this, this is a standard form quadratic. We have m squared minus 14m plus 48. We have square, first power, 0 power. So this is what we're used to seeing when we solve these quadratic things. And so this takes a higher order quadratic, something that has a degree larger than 2, and puts it into a quadratic form. And I shouldn't say this is a higher order quadratic. This is a higher order equation, higher degree equation. So it takes this higher degree equation and puts it into a quadratic form. Okay, so now that it's in a quadratic form, we can go ahead and try to solve this thing. So we can use any of our different types of solving techniques. I'm going to go ahead and use complete the square, since that's what we used last time. So remember that the first thing we need to check for in complete the square is, what is our leading coefficient? Well, leading coefficient is the number in front of the number that has the degree on it. So it's 1. That's good. We want our leading coefficient to be 1. If it isn't, we'd have to divide it off. Okay, so since it's 1, we can move to the next step, which is to take the c term over to this side, leaving us with just the variables. So I'm going to go ahead and subtract 48 from both sides. And that's going to give me m squared minus 14 m equals negative 48. Okay? Now we need to actually complete the square. We need to make this a perfect square trinomial. And remember, that means that we need to add something to both sides that is half of this number squared. So half of 14 squared. Okay, well, half of 14 is 7, and 7 squared is 49, so we will be adding 49 to both sides. So now we're going to have m squared minus 14m plus 49 equals, let's go ahead and add 48 and 49. Negative 48 plus 49, of course, is positive 1. So equals 1. All right. So now that this is a perfect square trinomial, remember, perfect square trinomial, this middle term, half of it squared, it should be the third term. Now this is a perfect square trinomial, we know exactly how this factors. We take this variable, whatever this variable is, and drop it down. So we have an m that drops down. Then we take this sign, whatever it may be, positive or negative. Okay, Victor, yeah, so let me back up real quick for Victor. So the 49, again, comes from trying to complete this square here. We need to take this side here, m squared minus 14m. We need to take this and force it to be a perfect square trinomial. Now we can add whatever we want to both sides of an equation. As long as we do it to both sides, it'll keep balance. That's perfectly fine. Now, specifically, to make this thing a perfect square trinomial, we need to take half of this number and square it. So half of 14 is 7, and then 7 squared is 49. That gives us the number that we want to add to both sides in order to make this a perfect square trinomial. Again, the reason we want to make this a perfect square trinomial is because we know exactly how those factor. They'll always factor the same way. And then, of course, we will also add 49 to this side just to keep that balance. So, does that help, Victor? Okay, thank you. So, like I was saying, we now have this as a perfect square trinomial. This middle term, if we take half of it and square it, is the same as this term. So because this is now a perfect square trinomial, we know how this factors. This variable, whatever it may be, we will take it and drop it down. So m will drop down. This sign, again, whatever it may be, we will take it and drop it down. So we're going to have a minus that drops down. Then we will take half of this number and drop it down. So 7 comes down, and the entire thing is squared. And that is the factored form of this right here. If we take this and factor it, it gives us this. And it is still equal to 1. Okay. So now we can go ahead and solve this since we have a factored form. We no longer have that square term getting in the way of us solving this. So, first things first, like we've said before, if we have parentheses like this where maybe there's something multiplying by it or there's a square, we need to get rid of that so we can unlock the parentheses, get these numbers out of there. So, again, whether it be like a number out in front multiplying by it or a square or a cube or whatever, we want to get rid of one of those things. Here, in this case, we have a square. We need to get rid of that by doing the opposite, which is a square root. And, of course, to preserve balance, we will do that to both sides. So taking the square root on this side, that means that we have just m minus 7 left over. And then taking the square root on this side, the square root of 1 is plus or minus 1. Only one thing left to do now, and that is to take the 7 to the other side. So we will need to add the 7. Add the 7. And that gives us m is equal to 7 plus or minus 1. Okay, so we really need to figure out the two answers that we have here. 7 plus 1 would be 8. And then 7 minus 1 would be 6. So M could be 8 or 6. However, remember, we're not done here. M was just something that we replaced x squared minus 1 with. We said that we recognize that these factors repeat in this equation. And if we were to multiply things out here, we would get a higher order or higher degree polynomial. Something that we actually don't know how to tackle. We know how to tackle quadratics pretty well. We just don't know how to tackle those higher degree equations very well. Not at this point in our math career. So we can take these x squared minus 1s and make them m. And that way we have a quadratic. We can solve that quadratic, which is what we did. We solved this quadratic. Now we need to say, okay, hold on. We need to actually put this answer back into here. So we will go ahead and do that. So we'll have two different cases. One where we're going to put 8 in for x squared, because that's one of our answers. So 8 squared minus 1. And then another one where we put in 6 in for x squared. Again, that's our other answer. Okay. So let's go ahead and see what we get. Oh, I'm sorry, that's completely wrong. I put that in the wrong place. So remember that m equals either 8 or 6. So m is the thing that's going to get the replacement. Sorry, I didn't sleep well last night. So x squared minus 1 could be 8. Or x squared minus 1 could be 6. Again, we said that m is equal to either 8 or 6, so we put 8 or 6 in for m, and now we need to solve each of these situations here. Okay. So, first things first, let's tackle this one. We will need to add 1 to both sides. That gives us x squared is equal to 9. And then take the square root of both sides to get rid of that square. And that leaves us with x is equal to plus or minus 3. Okay. This one, same thing. We need to add 1 to both sides. That gives us x squared is equal to 7. Then we need to take the square root of both sides to get rid of this square here. That gives us x is equal to plus or minus the square root of 7. Of course, we can't actually take the square root of 7 and get something that isn't irrational. We need to keep it this way. Okay, so what we get here is 4 different answers that could possibly work for x in this equation here. We have that x could be positive 3. We have that x could be negative 3. X could be positive square root of 7. X could be a negative square root of 7. All 4 of these answers would work. They would make this thing true. Okay, so any questions here? I know this is kind of longish, so I'll leave us open for some questions on here. Okay, I'm not seeing any questions, so I'll move on. So I've got another one here. Same idea. Just get some practice on this. So we've got x squared minus 7 squared plus 3 times x squared minus 7, which is to the first power, minus 10, which is 0 power, equals 0. Okay? So we have, again, a quadratic, but we just need to kind of help it along the way to being in a quadratic. So we're going to say x squared minus 7 repeats. We're going to replace that with something. Again, I like to use m. The reason I actually like to use m is because this technique was taught to me by one of my math professors named Dr. Moyo. And he always said that m stands for Moyo. Fantastic professor, by the way. So we're going to say that m, in this case, equals x squared minus 7. So we're going to replace everywhere that we have an x squared minus 7 with m. So we will now have m squared plus 3m minus 10 is equal to 0. Okay, so again, this is a quadratic, and lucky for us, again, we have a leading coefficient of 1. The number out in front of x squared is positive 1. So we don't need to worry about kind of finagling things to make it do what we want to do. We can just go directly into completing the square. So again, our first step here is to take the constant term and bring it to this side. So we're going to add 10 to both sides. Oh my God. So now we have m squared plus 3m equals positive 10. All right. Now this is going to get a little tricky because remember that what we need to do now is take half of this and square it. Well, what's a half of a 3? Well, the easy answer there is that it's 3 halves, or 3 over 2. Okay, then 3 over 2 squared is 9 over 4. So we're going to be adding 9 over 4 to both sides to complete the square here. So m squared plus 3m plus 9 over 4 equals 10 plus 9 over 4. Okay, so we are going to have to deal with some fractions here. This is why fractions, it's important to know how to use them. Again, I've always felt that fractions can be your best friend if you know how to get along with them. So, 10 plus 9 over 4 is going to be 49 over 4. So now we have m squared plus 3m plus 9 over 4 equals 49 over 4. And then we need to go ahead and factor this. Again, this is a perfect square trinomial. We went ahead and took half of this and squared it, added it to both sides, so this is a perfect square trinomial. So, like I've said before, they all factor the same way. We take this variable here, drop it down. Take this sign, drop it down. Take this and take half of that, and drop that half down, so 3 over 2. And the whole thing is squared. Then this just comes down, nothing interesting happens with it. Still 49 over 4. Okay. So now we have it in a form that we can solve. We'll go ahead and do that. We need to get those parentheses off of m plus 3 over 2. So, like I said before with the previous example, we need to take the square root of both sides. So take the square root, take the square root, and I'm going to bring it up here so I have a little bit more space. So if I take the square root of both sides, this will now just be m plus 3 over 2. Now here, I can actually take the square root of this number, 49 over 4. If we take the square root of the numerator and denominator, that's 7 over 2, plus or minus 7 over 2. Okay. So now we need to get m by itself. So I will need to subtract 3 over 2 from it. And subtract it on this side as well to, again, preserve that balance. So now we have m is equal to negative 3 over 2 plus or minus 7 over 2. So let's find the two actual values that we have here. We want to actually do the plus and the minus. Okay, so if we do plus negative 3 over 2 plus 7 over 2, that's really like 7 minus 3. That's going to be positive 4 over 2. And 4 over 2 is 2. So m could be 2. All right. Then we can do the subtraction part of the plus or minus. So negative 3 over 2 minus 7 over 2. That's like negative 3 minus another 7. That's going to be negative 10 over 2. Negative 10 over 2 is negative 5. So there's our two answers for m. And remember, this is not our answer. All we have done is found the value for the thing that we substituted in. Now we need to take these values and substitute them back into this m right here. So, x squared minus 7 could be positive 2. Again, we're taking this and we're plugging it in for m. Or x squared minus 7 could be equal to negative 5. So let's figure out both of these cases. So if we add 7 to both sides here, oops, 7, that means that we have x squared is equal to 9. And then take the square root of both sides to get this square off of x. And we have x is equal to plus or minus 3. Okay, so there's two of our answers. We need to get the other two from here. All right, so add 7. Add 7. That means that we have x squared is equal to 2. Take the square root of both sides. And x is equal to plus or minus the square root of 2. And there's our four answers. Once again, our answers here are x could be plus 3, x could be minus 3, x could be positive square root of 2, x could be negative square root of 2. Four answers. So like I said before, the reason that we use this substitution thing is because if we look at our original equation, we can force it to be in a more normal or standard quadratic form if we replace these repeating factors with m. And that helps us solve it. Okay, so I'll give us a few minutes. Okay, so let's keep going. So another thing that you might encounter is something called a rational expression. And so rational, remember, means fraction. So these are expressions that are made up of fractions. So let me give you an example. Let's have x squared plus 10x plus 21. And then this will be over, let's see, actually I don't like that one. Let's do a different one. Change this a little bit. Three x squared minus 8y, I'm sorry, minus 8x minus 35, and this will be over no, you can see other things with fractions, and we'll probably get into those today. Just remind me if you want more examples. Y squared minus 9y plus 20. I'm sorry, x squared minus 9x plus 20. Okay, so again, rational expressions are expressions that are made up of a fraction. So how are we going to tackle this? Well, there's a few things to keep in mind. First of all, if we see quadratics like this, we probably want to factor them. And in fact, factoring quadratics and factoring any part of a rational expression might help you simplify it. And we would really like to have fractions as simple as possible, really. So let's try simplifying or factoring these expressions. Okay. So 3x squared minus 8x minus 35. Let's see if we can use the AC method on that and try and get this thing to factor. So 3 times 35 is 105. It's going to be negative 105. And we need to find factors of negative 105. Well, 105 can be divided by 5 for sure. That's 5 and 21. Let's see, what else? Can be divided by 3. 105 divided by 3 is 35, which we already knew. How about 15? Yeah, 15 and 7. Okay, and that's actually the one we are looking for. So if we make this positive 7 and negative 15, negative 15 plus 7 gives us the negative 8 we're looking for in the middle here. So I'm going to use the box method to factor this then. So draw up a box, split it up into 4 pieces. First term goes in the first box, so 3x squared is going to go here. Last term goes in the last box, negative 35. Then we can put either of these into either of these boxes. I'll put 7x here. Its sign will come along with it and sit outside. Then negative 15 has to come here. And that's 15x, and its sign sits on the outside. So, factor our rows and columns. This row has x in common. This row has 5 in common. This column has 3 and x. This column has 7. So the two factors are 3x plus 7 and x minus 5. All right. So I'm going to back this up a little bit so I can have more room for factoring this part. Okay. So let's try the AC method on this one. So this is 1 times 20 to get an AC of 20. 20 is 1 and 20, 2 and 10, 4 and 5. And we need a pair that's going to give us -9. Well, that'll be -4 and -5. So again, box method. And fill in those blanks. So first term goes in the first box. X squared. And then last term goes in the last box, 20. These two I can put in either of these two boxes. So I'll just put -4x here. And I'll put -5x here. So now I need to factor my rows and my columns. So this one, we just have x. This one has 5. This one has x. And this one has 4. So our two factors are x minus 4 and x minus 5. So after factoring this whole thing down, we get this. Now something you should notice is that we have x minus 5 in common between top and bottom numbers. That means we can actually cancel those out. But there's something else we need to do. So I'm going to go ahead and cancel those out to simplify this down to 3x plus 7 over x minus 4. But there is something else that we need to do in order for us to be done here. So this is fine. This is a perfectly fine simplified form. But rational expressions have kind of a problem that you need to keep in mind, somewhere in the back of your mind. And that is that the bottom part can never be equal to 0. Oh my goodness. Okay. So this part can never be equal to 0. Why is that? Well, if this bottom part, for some reason we plug in something for x and get 0, that would mean that we're dividing this by 0. And we cannot do that in algebra. So we need to actually figure out what would make this thing 0. Well, luckily, we have a factored form, something that's actually pretty easy to solve. If this can't be equal to 0, then the factored form also cannot be equal to 0. So we know that our factored form is x minus 4 times x minus 5. So this also can't be equal to 0. And now we can use our zero product principle to say that both of these can't be equal to 0. Remember what that says is if we're multiplying two things, which we're multiplying x minus 4 and x minus 5, If we multiply multiple things and they come out to be 0, then both of these things would be 0. Well, here we're saying both of them cannot be equal to 0. So x minus 4 cannot be equal to 0. X minus 5 cannot be equal to 0. So solve these and we get that x cannot be equal to 4 and x cannot be equal to 5. This is important to have. This tells us what we cannot plug into here. This is what's called a domain. And so a domain is all of the things that x can be. And what our domain is telling us here is that x can be anything as long as it is not 4 or 5. If it's 4 or 5 exactly, then that breaks this whole thing. Really, it breaks this whole thing. Okay. So, when you encounter one of these things that's a fraction like this, factor. Factor and try and see if you can cancel anything out, like we did here. So we factored this, canceled things out, we got a simplified form. Cool. So if one of your questions says simplify, that's what it wants you to do. It wants you to factor, see if you can cancel anything out, and then give us a simplified form. But remember, you also need to find excluded values, values that are not in your domain. So, like this case, we had x squared minus 9x plus 20 on the bottom, and we said, doesn't matter what's on the bottom, just cannot be equal to 0. So we take that, say the factored form also can't be equal to 0, then solve and figure out what we cannot have x be. So I know we're running a little over time, but I'm going to do one or two more examples, but I'll give us some time to ask questions on this one as well. All right. So let's try. Let me find one. Yeah, that one looks good. X plus 2 over 3x minus 3. And multiplied by x squared plus 2x minus 3 all over x minus 3. Okay, so here we have one rational times another rational. Same idea though. We want to factor all of the pieces and parts of this as much as we possibly can, see if we can get any kind of simplification here. Also, we all need to find any excluded values, anything that we can't plug in for x. So, let's actually start with finding the things we can't plug in for x first. So we have two things on the bottoms here. One of them is 3x minus 3. And again, like I said, does not matter what is on the bottom, it just cannot be equal to 0. So we move 3 to the other side. We get 3x is not equal to 3. Divide by 3 on both sides to get x by itself. And we have x, cannot be equal to. X cannot be equal to 1. So there's one of our excluded values. The other one, x minus 3, again it's on the bottom, and it does not matter what is on the bottom, that thing cannot be equal to 0. So x minus 3 cannot be equal to 0. Add 3 to both sides. That means that x cannot be equal to 3. Okay. So now let's actually start factoring and seeing if we can simplify this thing at all. So first, let's start with this one, x plus 2. So can we use GCF factoring? Do they have a GCF in common? Well, x and 2 don't have anything that they can both be divided by, so no, there's no GCF. Is it a difference of squares? Again, this is not a square, this is not a square, this is not a difference, so no, it's not a difference of squares. Is it a quadratic? Do we have an x squared in here? No. So this thing, I don't see any way to factor it. It is already in simplest form. Okay. How about the denominator there? 3x minus 3. Again, start up at the top. Can we use GCF factoring? Does 3x and 3 have something in common they can both be divided by? Absolutely. They can both be divided by 3. So let's go ahead and take that out. That leaves us with x minus 1 on the inside. Okay, do we have a difference of squares? Well, we have a difference, and 1 is technically a square, but x is not a square, so this is not a difference of squares. It's pretty close, not quite. Is this thing a quadratic? No, we don't have x squared in there. So this is as far as we can go with factoring that part. Okay, multiplied by, well, this is obviously a quadratic. We can obviously factor this thing. So let's go ahead and factor it. AC method 1 and -3 give us -3 for our AC. Then we can use, let's see, 3 and 1 to get 2. That'd be +3, -1. And so we can actually factor this thing down. I'll just save us some time since we are running overtime, and say this is x minus 1 and x plus 3. Okay. Then the top part, I'm sorry, the bottom part here. X minus 3, again, can't be factored. It's already as simple as we're going to get it. All right. So, at this point, now we need to see if there's anything common between the top and bottom. And yes, I actually do see something that is common. X minus 1 and x minus 1. It does not matter if they're on different fractions here. Since we're multiplying both these things together, you could kind of imagine that this is all one. Oops. That this is all one fraction. Again, multiplying fractions just means that you multiply the tops and multiply the bottoms, so we'd get the same thing if this was all one fraction. So like I said, since x minus 1 and x minus 1 are common between top and bottom, we can cancel them out. And so that will leave us with x plus 2 times x plus 3 all over the 3 that's left over here times x minus 3. And there we go. This is the simplified version of this original thing, and we also have our excluded values, things we can't plug in for x, otherwise we'd get 0 on the bottom. And again, we don't want 0 on the bottom because that would mean we're dividing by 0. Not good. Okay. So that is actually all I want to go over today. Now remember, test tomorrow. Test over Chapter 2. In a few minutes here, there'll be a review on Hawks going live. Just make sure you do that review. If you have any questions, again, remember, you can always email me with any kind of questions. My office phone also redirects to my cell phone. But for now, are there any questions on this example? Oh, while I'm waiting for questions, I'll mention this. Midterm grades are in. If you want to know your midterm grade, you can look it up on Banner. If you have any specific questions about your grade, of course, you can ask me about it. So the midterm grade at this point is based on the tests that we've had, the quizzes that we've had, and those reviews, the homework assignments on Hawks, the reviews, I mean, that we've had so far. And from what I've seen, most of us are doing pretty good, which is nice to see. Okay, I'm not seeing any questions. So here's how that test is going to work. Again, it's going to go live tomorrow at 1 o'clock. I will send out an email before the test telling everyone to get onto the test and take it. However, there will also be a document attached to it, attached to the email, that I need you to sign digitally. Basically, just download that document, put your name where it needs your name. That document is basically just like, please don't cheat, and you're going to agree to not cheat. And you need to send that back to me through an email. In fact, I will not be taking any grades from anyone I don't have that document back from. You need to give your digital signature on that code of ethics document. Okay? So if you want to get a grade on that test, make sure you download that document, put your name on it, and send it back to me. All right. But that will do it for today. So, again, things to remember. Your grades for the midterm portion of the semester are in. If you want to know your midterm grade, go to Banner and look it up. 2, review is coming in a few minutes here. It will be up by 12. So by 12, you need to be looking on Hawks and finding that review, getting into it, and starting it. 3, test tomorrow. It will be going live at 1 p.m. Okay, and you will have a time limit. I'm going to give you 2 hours to do that. It's more than you will need on this test. Okay, and probably most importantly, make sure that you get the email from me tomorrow that reminds you of the test. Download the Code of Ethics document, sign it, and give it back to me. Again, signing it just means type your name in the place that you need to type your name. Okay? So, that'll be it for today. I will see you on Wednesday when we will be going over the test. Goodbye for now.